The reaction mechanism of halogenation of alkanes can be divided into three steps: initiation step, propagation step, and termination step. Let's have a look at the mechanism of the monochlorination of methane. So the product form is chloromethane and the HCl as our side product. The initiation step involves the homolytic cleavage of halogen molecules by the presence of light or heat as the source of energy to form the free radicals. The sigma bond in the chlorine molecules will break symmetrically and each chlorine atom will get one unpaired electrons. So this is how the radicals of chlorine form. In the propagation step, the radicals that are formed in the initiation steps will react with our alkanes to generate the new radicals, which is the alkyl radicals that will advance the forward reaction. In the propagation step, the radicals that are formed in the initiation step will react with our alkanes to generate new alkyl radicals that will advance the forward reaction. So, from the methane condensed structure, I'll just take up only one carbon-hydrogen bond to show the formation of the metal radicals. Okay, so since carbon and hydrogen will break symmetrically, right, each atom will get one unpaired electron, right? So here it will give us the carbon radicals, which is the metal radicals, and the hydrogen radicals will combine with the chlorine radicals to form hydrogen chloride molecules. Next, the free radicals of alkyl group will react with the halogen molecules to form the haloalkanes, which is our product, and also another halogen radicals. To show the movement of electron, so as usual, I will start with our molecules. Okay, so since chlorine will break symmetrically, each chlorine atom will get one unpaired electron, and one of the chlorine radicals will bond it together with the alkyl radicals to form the haloalkanes. So the regenerated of chlorine radicals here, actually it will propagates the chain by repeating these two reactions until the supply of all our reactants are gone. In the termination step, these two radicals that are formed from the initiation and propagation step will combine with each other to form a molecules with all electrons paired. This chlorine and metal radical will combine with each other in three ways. The first one is the chlorine radicals combine with its radicals itself and form the chlorine molecules, right? The second way is the metal radicals will react with its radicals, right? So it's combined together to form another alkene molecules, which is ethane in this case, right? And then last but not least, the metal radicals can react with the chlorine radicals to form the haloalkanes. So the haloalkanes will form in the propagation and also termination step. Now, let's have a look at the second example. So here I have a propane undergoes monobromination. Okay, so since propane got two different type of hydrogen, okay, it is non-equivalent type of hydrogen. So we know that when propane undergoes monobromination, it will give two different haloalkanes product. So if we remove the hydrogen from this carbon or this carbon, since these two carbon are equivalent to each other, it will give us the same product, which is 1-bromopropane. So let's say if I substitute one of the hydrogen from this carbon with bromine, so I will get the 1-bromopropane. But if we substitute the hydrogen on the secondary carbon here with the bromine, the product form will become 2-bromopropane. And don't forget our side product, which is the hydrogen bromide, right? So based on these two products, the one that are formed from the more stable carbon radicals will become the major product. So since the secondary carbon is more stable than primary carbon, and since we know it is easier to break the carbon-hydrogen bond from the secondary carbon because the bonding is much weaker than in primary carbon, so the 2-bromopropane is our major product. So in this example, I'll just gonna show the mechanism of the formation of major product. Right, so the first step involves the initiation step. So we are going to break our bromine molecules, right, homolytically. So don't forget the UV here as the source of energy. So break the bromine molecules homolytically. So now each bromine will get one unpaired electron. So this is our bromine radicals. Next, in the propagation step, okay, so we are going to react our alkanes with the bromine radicals. Okay, so here I will use a skeletal structure, okay, to show the mechanism. So since here propane got 3 carbon, so I'll use the skeletal structure, and then the formation of the major product, alright, is where the hydrogen on the secondary carbon here is replaced with the bromine. So since the second carbon here got 2 hydrogen, so just take out the bonding, right, of the 2 hydrogen, and then this propane will react with the bromine radicals that are formed in the initiation step. Okay, so the reaction will only occurs on one of the carbon hydrogen bonding here. So let's say I'll make the reaction on this bonding. Alright, so first I'll break the bonding between the carbon and hydrogen homolytically. So hydrogen will get one unpaired electron, carbon also get one unpaired electron. Okay, so here our carbon radicals will form, okay, which is our secondary carbon radicals, and then right, the hydrogen radicals will will combine together with the bromine radicals and form the hydrogen bromide molecules, which is our side product. And then the next step in the propagation step is take the carbon radicals, our alkyl group radicals here, react it with the halogen molecules, which is the bromine molecules. So first, we are going to break the halogen molecules. Okay, so one of the bromine here will combine with the alkyl group radicals. So it will form our product, which is 2-bromo propane, and also it will leave us the bromine radicals. For the termination step, okay, all the radicals will combine to each other in 3 ways, right? So Br radicals combine with Br radicals, it will become Br2 molecules, right? And then the alkene radicals, right? So alkyl group radicals combined with its radicals, okay, it will become an alkenes. Okay, so now for this one, okay, to show the formation of the product from the combination of these radicals, okay, so let's draw the first radicals. Okay, so we have this one. Okay, so since the unpaired electron is on the second carbon, which is this carbon, so the bonding will occurs here. Same goes to this one. Okay, so if you label it, okay, so since the bonding will form from this carbon, okay, so let's say we label it as 1 and then 2 and then this one is 3. Okay, so we know that the one that is bonded to this carbon is the first carbon, and then we have second carbon, and then the third carbon is beside the first carbon. Okay, so this is the product from the combination of these radicals. And then for the last one, okay, we have our haloalkanes, which is 2-bromo propane. Okay, so that is the reaction mechanism of the formation of major product for the monobromination of propane.